this video, we're going to go over the idea of getting information of the original function f when you have information only about the derivative f prime. So in other words, f going from f prime to f. And we know that in some sense the fundamental theorem of calculus is really just saying that. When you, in order to get to f from f prime, what you do is you integrate it, right? Well, what we're going to do here is use that same sort of principle, okay, but what we're going to be given now is not a formula, but a table. Alright? And so what I've written here is a table of the marginal cost of something, and so we know that that marginal cost is a derivative, or it's the derivative of the cost function of whatever business this would be a function for. And the question we're going to ask is, how much does 400 items cost to produce? Alright, and so the key thing here is, how much does it cost? So we want to know something about the cost function, and all we know are things about the marginal cost function. Alright, so remember, this is distinct from how much does the 400th item cost. That's not what I'm asking. I'm asking how much does it cost to produce 400. So from the first item all the way up to the 400th item, how much does making all of those items cost to produce? Alright, so let's get to it. So what's the idea here we're going to use? The idea we're going to use is that this derivative, alright, this MC is the derivative of the cost function, but it also represents the marginals. In other words, how much each item is actually costing. So how are we going to figure out how much it costs to produce 400 items? Well, all we're going to do really is add up how much each item costs. And that sounds really simple, but of course there's a little bit more to it than that. So we only know the cost of the first item, the 101st item, the 201st item, the 301st item, the 401st item. And so how are we going to get the cost of the first 400? Just knowing that information. And so the best way to do these kinds of problems is to actually turn the table into a graph. Alright, and remember here, how much? Well, since we have a table, all we're really going to be able to do is estimate this value. Okay, so we're going to make a key assumption here, and you'll see where I'm going to make it. So here's a graph that I'm setting up. The y-axis is going to represent marginal cost. Okay, and then we have the marginal cost for up to at 100, 200, 300, and 400. Okay, and you see here, let's write, I'll do it in well, I'll keep it in white here. So we have 25, we have 28 slightly above that, we have 22 also slightly below 25. Alright, it's a little bit out of scale, but you get the idea. There's 18 down here. Well, let me draw 20 first, and then 18 down here. Okay, so let me just draw some points here. So at 0 the marginal cost is 25, and this is of course in dollars, and 100, nothing fancy, it's just 100 represents 100 items. So at 100 the marginal cost is going to be 20. At 200 it's going to be 18, but then it increases at 300 up to 22, and then it increases up to 28. Okay, so we can see that the marginal cost function looks like it might be concave up, it might actually be concave down later, we don't know, but the fact is that it decreases and then it increases. Alright, so we don't know exactly what's going on in between, but since we just want to estimate the cost of producing 400 items, what we're going to do is pretend that we can connect these dots by lines. Okay, just like that, just like that. Okay, you get the idea. Okay, and now from the fundamental theorem of calculus, we know that when we have the graph of a derivative, in order to get to the original function, all we have to do is integrate it over whatever region we want. In this case, we're going to go from 0 to 400, right? And we notice that this graph is above the x-axis, or the q-axis in this case. And so all we're really going to find is the area under this curve, the actual area under this curve. That's what the integral is going to give us. All right, so we look here. I'm just going to start drawing these little regions. So all we're going to do now, the goal is to, so let me write this down, integrate from 0 to 400 the function mc of q dq now, since the variable is dq. Okay, I'm just going to integrate this function over this region 0 to 400. And, well, we can cleverly split up each of these regions. We see there are about 1, 2, 3, 4 regions, one between 0 and 100, another between 100 and 200. You get the idea. And I'm just going to split up these regions into nice shapes that I can actually find the areas of very easily. So you see, I'm just choosing these drawing these lines here, so that's very easy for me to compute the area. Okay, so let's start with the yellow ink. Let's go to this box here on the very bottom left corner. Well, you see the area of this box, let's say in yellow. Well, actually, let's number it. Let's make this triangle, or this square, A. Let's make this B, C, D, E, F, G, and H. Alright, so there are 1, 2, 3, 4, 8 regions we have to compute the area of. Let's go to area A. What's that going to be? That's just going to be 100 times 20. Right? 100 times 20. That, of course, is just 2,000. Okay, that's one. Let's go to area B. That's a triangle now, so we're going to do 1/2 base times height. So we have 25 down to 20, so that's 5 times 100, that's 500. So let me write that out. It's 5 times 100. But I have to divide by 2 because it's the 1/2 base times height formula of a triangle, and we get 250. Okay, now let's go to area C. C is going to be 20 minus, well, let's write down 1/2. This is a triangle, so 1/2, what's the base? It's going to be 100. What's the height? The height is going to be 20 minus 18, which is 2. So that's just going to give us 100. Okay. Let's go to area D. The area of D, well, that's just a rectangle, so length times width. The length is going to be 100 times the width, which is going to be 18 minus 0, which is 18. So that's going to be 1800. Alright, so far so good. E is going to be a triangle, so that's going to be 1/2 base, which is 100, times the height, which now is going to be 22 minus 20, which is 2. Oops. Actually, it's going to be 22 minus 18, which is 4. And that's going to give us 200. Alright, if we go to F, well, that's a rectangle, so it has length 100 and width 18, so we're going to get 1800. let's go to G and H. G is a triangle. Its base is 100. Its height is 28 minus 22. And so that's going to be 6. So 1/2 times 6 times 100. That's going to be 300. And then H, well, that's a rectangle, base is 100, and the height is 222, so that'll be 2200. Okay, and so since we wanted to find this area, remember, the integral, we want to find what that's equal to, all we have to do is add up all the areas of the smaller regions that we divided it up into, right? And so let's see what we get here, just adding them one by one. 2,000 plus 250 is 2,250, plus 100 is 2,350. 2,350 plus, so let's put 2,350 here, plus 1,800, that's going to be 3,150, plus 200, that's 3,350, plus 1,800, that's going to be 4,150, right? Plus that's plus 800, so plus 1,000 is 5,350, so we'll put another 5,350 here. And then we'll put an arrow, alright? And then plus 2,200 plus 300, that's plus 2,500, so we're going to get plus 8,850. So actually, I feel like I calculated that wrong, but hopefully you can check. Well, alright, let's just go over that really quickly again. So this first part is 2,350. The second part is going to be 1,800 added twice, that's 3,600, plus 200, that's 3,800. And then the last part is 2,500. So if we add all those numbers up, we're going to get 2,350 plus 2,500 plus 3,800. That's going to give us, well, 4,850 plus 3,800. That's going to give us 8,650. Alrighty, and there you have it. That is the cost to produce 400 items if the marginal cost is given by this chart. Okay. If you were asked to find out how much 400 items cost to produce when you have an additional fixed cost of, let's say, $10,000, then what you would do is the same exact thing, except at the end you'd add 10,000 to this number, 8,650. All right, this is what's known as the variable cost. All right, and fixed cost will just be something that you add to the variable cost. And that's it.